which will go through the lungs, get oxygenated, return to the left side of the heart, and begin my arterial side again. So, a little tiny red blood cell. And how many did it say we produced per day? About 400, was it 400 or 200? 200 billion per day. They have a lifespan. Of about 120 days. They make a trip from the left side of the heart back to the right side of the heart about every minute. They're busy, okay? When they are formed, they are considered an erythrocyte, okay, a reticulocyte. They are considered to be formed as an immature cell that will make its way to the bloodstream for about 3 to 4 days. It will mature and become an erythrocyte, which would be the red blood cell. Now, one of the things that happens with the red blood cell, in that cell, okay, let's think back to our cell having the nucleus with the DNA. On that DNA are the genes, okay? What protein is needed in the red blood cell? Do you happen to know what transports oxygen? Ever heard of hemoglobin? So think about this for a second. In its immature form, the gene that will be open and working very hard is the one that codes for hemoglobin. Because the goal, by the time it becomes the mature red blood cell, make sure that this cell is full of hemoglobin. Is everybody with me? Okay? Now, as it goes through doing that for roughly about 3 to 4 days, by the time it considers itself mature, it spits out the nucleus and the organelles. Because the only thing it wants to have is hemoglobin. Because its goal, transport oxygen. Okay? So, once they spit their organelles and their nucleus out, the way that they'll get energy is anaerobic fermentation, meaning they don't go through cellular respiration. But that's okay. They work pretty good on doing anaerobic respiration. They're not having to utilize oxygen. They want to simply carry it, transport it. So the structure becomes what looks like, to me, a donut. All right? It's concave on each side. The cytoplasm that will exist. Now, this is where things will get a little interesting with the red blood cell. It contains an enzyme, and remember, enzymes are used for carrying out some type of chemical reaction. it has the enzyme carbonic anhydrase. Let's take that term apart. Carbonic. Have you ever heard of that? How?
Carbonic acid.
Carbonic acid. Where do we find that? What's a good source of that? Or how have you heard about carbonic acid?
I feel like it's I just don't know. I can't remember.
Oh, you're gonna remember. Madeline, can I use your Sprite?
That's it.
The Sprite that's back there. Okay. Now, once again, show y'all the dinosaurs I am. Okay. I can remember when the only way to get a soda was from the soda machine. Okay, you would literally go to like the local, it was like the Woolworths, the might have been like a counter that they had at the pharmacy. Okay, they actually had the soda machine, and it was so much fun to watch them change the tanks out. Okay, because then you got to see when that first cup that got made, everything's spewing all over the place. Okay, now they just simply have a machine and it just simply injects the carbon dioxide into the liquid. So, sodas are an excellent example of having carbonic acid because they have injected into the fluid, whatever the fluid is for making Sprite, to make it fizzy bubbly. Okay. All right. So, to make it fizzy and bubbly, they simply have the little thing go in and whoosh, and make it fizzy bubbly. It's carbon dioxide. Sodas are a little bit acidic. Not great, okay, because carbonic acid is not anything that's terribly acidic, even though I have heard that you can clean rust stains out of a toilet with Coke. So I guess it could be a little bit acidic, couldn't it? Anyway, okay, so carbonic acid, carbon dioxide. What did we produce?
Carbon dioxide.
Carbon dioxide, which is going to make its way to the bloodstream, and in the presence of the fluid, i.e. water, that is there, what do you think it's going to do to pH of the blood? Bring it down. It will make it acidic. Hold up. I just said a little bit ago, we cannot mess with the pH of blood. Right?
Mm-hmm.
So, the body needs to buffer this. In the red blood cell, it has the enzyme known as carbonic anhydrase, and remove. Okay? And that means it can take it, it can rearrange it, okay? Create a bicarbonate ion. Anybody ever heard of bicarb? Bicarbonate? Can you remember how?
I think sodium bicarbonate.
Sodium bicarbonate and okay, and think about like people might have upset stomachs, and you see on the stuff that you might take, like the Tums or the antacids or whatever, sodium bicarbonate.
So it's just like a neutralizer?
It's like a neutralizer to bring the acid down.
Because it's more basic?
It'll be basic, hitting an acid. When you put an acid and base together, depending on their concentrations, they can actually neutralize.
Yeah.
And we need that in the blood. Red blood cells will have the ability to do that because the goal is to get the CO2 to the lungs without it affecting pH of the blood. Because if I affect the pH of the blood, everything else it encounters is going to be affected also. And where does it encounter stuff?
In the tissue?
At my tissue level, which affects my cell. How did I say everything would be taught? At the cellular level. You mess with the cell, you mess with the tissue, you mess with the tissue, you mess with the organ, you mess with the organ, you mess with the organ system, you mess with the organ system, you mess with the organism. That pretty cool? They do if you lead them in that way. They are so used to addressing an issue as a whole and having to explain the issue to the person. Perfect example. A friend of mine, her daughter wasn't feeling well. And so she called and she was like, well, do you think it could be blank? And I said, well, it doesn't necessarily sound like that to me, but it will not hurt for her to go to her doctor and get some blood work done. So she goes to the doctor, gets some blood work done. My friend called me yesterday because the blood work had come back. And one of her hormones, which should not in any way have been active, was active. And I went, oh. I said, what did they tell her about that? Oh, just that she shouldn't be producing that right now. Oh, seriously? And you know, of course she was calling me because she wanted to know what was going on. And I said, well, here's what's going to happen. And I said, first of all, are they going to run any more tests? And she said yes. They were planning next week to do some more extensive blood testing. I said, okay. I said, because here's what's going to show up. I said, when those blood tests come back, I said, you're going to see this, you're going to see this, you're going to see this. And I said, next thing they're going to need to do, they're going to need to schedule an MRI of her brain. And I said, I am pretty sure, pretty positive, that it's going to come back as being a tumor on the pituitary gland. She goes, what? I said, don't get upset yet. Don't. And I started explaining to her what could happen. And I said, just let the path take its course. We'll see if I'm right. I said, if I'm wrong, great. That'll be great with me. I said, but I'm betting probably 98, 99% positive this is what's going to happen. So we'll see. But the doctors didn't in any way explain it to them like that. Because if without the background to guide the doctor, to talk to you about it that way, you got to understand it this way. And now, when you guys go or have a test or are told something, you guys are now going to be able to guide the doctor to talk to you about it on this level. Okay? Does that make sense? Now here's the